Just fill in the chart just so that you have a perspective of it. And Armand, was it you that asked me about the negatives? You'll see why today. Okay, so on here, we're at 0 radians here, and it makes little dashes here, and we all know that up here, this is pi over 2. We've done this before, but we're just doing it again. Pi, this is 3 pi over 2, and all the way around is 2 pi. Okay, now we know our smallest angle when we're talking about special right triangles, it goes 30, 45, 60, right? So this is our 30, which would be pi over 6. This would be our pi over 4, which is our 45. And this is our pi over 3. All of those are in between 0 pi and 1/2 pi. Now we're going to keep going over onto this side. And over here, this would be 2 pi over 3. This is 3/4 pi. And this is 5 pi over 6. Notice it goes 2/3, 3/4, 5/6, and then we're at 1 pi. It should kind of make sense. Okay, then we go down into the third quadrant, and this would be 7 pi over 6. This would be 5 pi over 4. This would be 4 pi over 3. And then we have 1 1/2 pi. Here's 1 1/6, 1 1/4. 1 1/6, 1 1/4, 1 1/3, 1 1/2. So it makes sense to you. The next one would be 5 pi over 3. We'd have 7 pi over 4. And we'd have 11 pi over 6. And then we have 2 pi. So it goes 1 1/2, 1 2/3, 1 3/4, 1 5/6, 2 pi. Does that all make sense? That makes the whole circle. Notice these. These are when we have our 30 degree, all of these that have 6's in our denominator. Jackie and Sarah, please listen. These 4, the reference angle, would all be 30. These 4 would all be 45. And the last 4 with the denominator of 3, because we're drawing up to the x-axis, will be 60. This measurement would be 60. Okay, so hopefully that even after we've studied a few days makes more sense than it did the first time that you saw this. Okay, so now we're going to go to the next page. And if you can, let's kind of just keep this one opened up. And on here, the next page. If you look at 0 degrees, 0 degrees, let's just put right here. Darn, I wish I had this right next to me. Hold on to your hats. I don't need anyone else. Do you have it filled out? Okay. Okay, so 0 degrees. And you guys can go, I just kind of, you know what, hold on. No, I don't want to shut that off, then I have to redo it. Okay, then I have to add 2 of them. Okay, hold on, Tyler. I'm going to just take this out so it helps with my explaining. Okay, because it helps with this next door. Okay, so on here, this is what you have on the other side, but you can watch up here. When we're talking about 0 degrees, it's right here. Remember, the cosine is the x. This is all 0. It's 0 radians, which is right here. Okay, this is all going to be in radians. Okay, so I did. Okay, so it is x. The cosine is the x, so this is 1 and 0. Let's go to pi over 2. Are easy ones. This is 0 and 1. This would be -1 and 0 at pi. This will be at, what would this be? At 0, -1. And at 2 pi, you're back home again, 1, 0. Now, what happens here? Okay, at pi, what we're doing is, think of this as the bicycle wheel. We're going and we're going to lay this out flat. So our first number is pi over 6, which has a reference angle of 30. 30. So my opposite, is that the x or the y? Or 30, is that the short or the long? Okay, so this, the x is the long. So this would be radical 3 over 2, and this would be 1/2. Radical 4, when it's over 4, that's a piece of cake. It's always radical 2 over radical 2. Oh, that's what I meant to say. Radical 2 over 2. 1/3, what's the reference angle? 60. So which is the longer leg? The y. So this is radical 3 over 2, and the short leg is the x. Notice they're just opposites. Okay, so now we go over to 2 pi over 3, that's 60. So it would have the same thing as this, right? It's always going to be 1/2 here. The short leg is the x, the long leg is opposite the 60. But what happened now, because we're in the second quadrant? Negative. What's negative? The x. The next one's easy, right? Because it's a 45 reference angle. And the other one will be a reference angle of 30, so that would match this. Okay, keep on going. Now, what happens in the third quadrant as far as the signs of them? They're both going to be negative. Okay, this is going to have a reference angle of 30, so the shortest leg is the opposite, which is the y, so that's -1/2. This is negative radical 3 over 2. Notice how these are all the same with the denominator of 6. 4 is easy. And this is -1/2, and I'm sure you're seeing a pattern by now. This one in the fourth quadrant is what? Which one's positive? Or which one's negative? Y. So this would be 1/2 and negative radical 3 over 2. This is radical 2 over 2, negative radical 2 over 2. And this would be radical 3 over 2 and -1/2. Going back to this, this would be going back around. It would just be repetitive of this. And I'll show you why I'm doing that. And this would be radical 2 over 2 and radical 2 over 2. Okay. Are we good? Okay. Now, what we're going to do is we're going to take, this is going to be our cosine. Y equals the cosine of x. This could also be written as y equals the cosine of theta. This we're going to graph down here as y is the sine of x, or it could be written as y equals the sine of theta. Okay. So what we're going to do is we're going to take this and we're going to start with here, and it's going to roll this way. So the first number, if you continue this like a number line, would be a pi over 6, then the pi over 4, then the pi over 3. Do you see how it would land? The pi over 2. This would be the 2 pi over 3. When you would roll it out and make this like a straight line. Is everybody understanding that? If I would take a shoelace and you would just roll it and make it a straight line, the circle to a straight line. So notice all of these here, here's from 0, or in the same order. This is how that wheel would roll out onto this graph. Okay, this goes up by 1 to -1. My amplitude is 1 on this. So what I'm just looking at, class, is just this top line. I'm going to just graph this top line. And I am first going to just graph, and they are called, and I'm losing what the name of them are, they are called they just call them 5 points, but Mrs. Hudgens calls them something else. Relevant points or whatever. It's this point, here, here, all of these that are at the axes. So if I would, remember this is my x, this is my y. So I am plotting 0, 1. I'm not doing this bottom. This is an x and y. This is your x. This is your x-axis right here. Right? This is the x-axis on this graph. So don't get that confused with this cosine of x. Okay, this is really your y here. So here's 0, 1. Got that? Then I am going to go down to here. This would be at pi over 2, what is y? 0. At pi over 2, the y is 0. Notice these are like two different graphs. This is your x, this is your y. Everybody understanding this? Okay, so now if I go here at pi, what is the value of the y? -1. And at pi, 3/2 pi, what is it? 0. And at 2 pi, it's 1. So you aren't looking at this second. This is your x, this is your y. This is your x-axis. Notice how it's all marked here. Here's your y. So now let's go back through this. Remember two things. Radical 2 over 2 is equal to about 0.7. Radical 3 over 2 is equal to about 0.85. Okay? So, at pi over 6, this is radical 3 over 2, so it's at about 0.85. I'm estimating right here. At pi over 4, it's at about 0.7. Remember, this is 0.5 here. At pi over 3, it's at 1/2. At pi over 2, it's at 0. At 2 pi over 3, it's at -1/2, so it goes down here. At 3/4 pi, it's at -0.7. 5/6 pi is at -0.85. And then at pi, it's at -1. At 7/6 pi, it's at radical 3 over 2, which would be -8.85. 5/4 pi is at -1/2. This will be at 0.7. And then we have it at 0. Once again, here we go again. 5/3 pi is at 1/2. This is at 0.7. This is at 0.85. And then we would go back around, and this is at 0.85. I said 87, I apologize. And this is at 0.7. If you connect the dots, this is what it would look like. So Armand, why those are negative is because of the graph that it goes down below. Okay? This is when you're undoing the whole wheel. If I look at a period here is 2 pi. It's the length of where it begins and ends, and then it starts repeating again over here. The amplitude is half the distance from the maximum to the minimum. So this goes from 1 to -1, so that would be 2, and half of that would just be 1. This is a standard cosine graph. Notice where it began, at 0, 1. Why does it begin at 0, 1? Because it's here at 0, it's 1, 0, and cosine is 1. Okay, so now let's go with the sine. Remember, I'm looking at this is x and this is the y. So when it's at 0 radians, as Camyar corrected me, it would be at 0 here. It starts at the origin. Here at 0.6, it's at 1/2. Then it goes up to 0.7. And then it goes up to 0.85. And then here it is at 1. Okay? Here, this is at 0.85, 0.7, and 1/2. 1/2, Cheryl. I almost missed the 1/2. And then it's back down to 0. At pi, the sine is 0. Here, then we go down here, 7/6 pi is at -1/2. This is -0.7, -0.85, -1. And this would be -0.85, -0.7, -1/2, and 0. And then we go 1/2 again, and point. So how does it go? It goes like this. What is the period of it? The period is 2 pi. What is the amplitude? It is 1. On this one, the 5 points here, I want you to see, do you understand how it rolls out? When you have to graph them, you don't have to make all those points. Yay. What you have to do is mark these key points, and you have to just put in those values. So you're going to be putting in these values, and we're going to have some practice. So it's the 5 points, the critical points. That was the word I was searching in my brain. And the critical points here, the 5 critical points on a sine are 0. Then you go to the maximum. Then it's back to 0. 0, Cheryl. And then it's minimum. And then it's back to 0. It's 5 critical points. For the cosine, it goes something different. It doesn't start at 0. What does it start with? And that's your maximum. And then it goes to 0. And then it goes to minimum. Something funny? And then we have 0. And then we end up at the maximum. This is at 0, this is at pi over 2, this is at pi, this is at 3/2 pi, and this is at 2 pi. I'm not going to have you do all the ones in between. You just have to do those 5 critical points. Okay? This is at 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. So to graph them, but I wanted you to have the understanding of why it goes like that and it curves. Okay? Okay, so let's finish up our notes here. Everybody good with this? Are you still copying it down? And I think this next part will all make sense. You gotta kind of sit back and relax for a moment. Okay. So, let me zoom in on this. Tell me. Yep, it's the last thing. Okay. So suppose y equals a sine b theta. A cannot equal 0, b is greater than 0, and theta is in radians. The absolute value of a is the amplitude. This is important. Amplitude is never negative because it's talking about the height above and below. So it's always a positive number. It is in here what we just got done doing. Right here, our A was 1, so my amplitude was 1. Okay, it's never negative 1. Okay, B is the number of cycles in the interval from 0 to 2 pi. And that's how many, and we don't really have to worry about that this year. This is the period of the function. So here you have 2 pi divided by 1, which is just 2 pi. So right here, this matches the measure of the angle in standard position. Here I just went through it. Here it's also in degrees. These would be your critical points. Right here are the 5 critical points. This is y equals the sine of theta. Notice the comparison here. What if all of a sudden my amplitude is 2? What happens to it? Instead of going here, remember we're doing the second one, so it starts at 0. Instead of going up to 1 for my maximum, it's going to go up to 2. So this is 1, 2. And how low does it go? It goes down to 2, but the amplitude is just 2. The difference between the maximum and minimum is 4, but you take half of that, which is 2. So all that does is just stretch it vertically. It's a vertical stretch. This was what we just did. My period was all just 2 pi, and all of yours are going to be 2 pi. We're going to keep it very simple. Andrea, can you wait about 5 minutes? Okay. So on here, if A is negative, look what happened to your graph. Instead of going from 0 to maximum 0, minimum to 0, it goes below. It's reflected over the x-axis. And it goes 0, then it goes minimum, 0, maximum, and then back to 0. Okay, 0, minimum, 0, maximum, 0. And where are these points? You have to put this in. Pi over 2, this would be at pi, this would be 3/2 pi. You're doing them at the axes, if you want to think of it like that. Okay, so now let's look at the cosine, last page. The cosine function of y equals cosine of theta matches the measure of the angle. Here's where it is. Notice it starts at 0, 1. It's maximum, 0, minimum, 0, maximum. Here are my critical points. Okay, so if I want to graph this, what would be my amplitude? 3. So if I just draw a line, this is all you have to do. Pardon? Oh, okay. So here I want you to mark off, here's pi over 2, here's pi, here's 3/2 pi, and here's 2 pi. You have to show me that because that's the whole period. You have to go through a whole cycle. Now, it always starts at 0, but how high is it going to go?
1.5.
It's going to go up 3, okay? It's going to go up 3 and it's going to go down 3, okay? Because my amplitude is A. A is the amplitude. So the distance between your maximum and minimum has to be 6 because the amplitude is 3. So now it's going to go here, 0, maximum, 0, minimum, and 0. And this is how you draw it. And you're done. Now here on this one, what is my amplitude? 1/4. So on here, and I'm going to let you go in a second if you have to go still. Here, this would be, we go pi over 2. You have to label these. 3/2 pi and 2 pi. If this is 1, and down here, whoa, it's -1, how high does it go? 1/4. So I'm going to make my 1/4 button here, so it's going to be like this. And then it goes to 0, and then it's going to go to -1/4 and here. And you just draw it like this. Now remember, you guys, that it keeps going on and on and on here. Okay? It doesn't just stop. It keeps going on. It continues the pattern. Okay, now this one has something different. It has a +2. So do you have any idea what might happen? I'm sorry, pardon us what? Very good. So if you have this, it's going to, my x-axis gets really transformed to here. So when you're starting at this point now. It got vertically shifted up to 0, 2. Okay? So now my amplitude is what, class? 3. It's always positive, but it's negative. So first of all, let's mark off our little marks. We have pi over 2. Are you writing this in, Abraham? Pi. This is 3/2 pi, and this is 2 pi. Okay? This is at 0, 0. Now, how much above and below is it going to go? It's going to go up 3 and below 3. 1, 2, 3, and below 1, 2, 3. Now, when this one goes, here's my 0, my critical point. Where is it going to be at pi over 2? -1. Good side, because it's negative. Instead of going from 0 to maximum, it goes from 0 to minimum. It's reflected over the x-axis. The negative affected that part. So here, if I go down 3, it will be right here. Now at pi, it'll be back to 0, which is y = 2, because it got shifted up. Here, this will go up 3, and this one will go down here. So what does it look like? It looks like this. Andrea, if you want to go now, you can.
But that doesn't follow the
Pardon?
That doesn't follow the max 0 and then 0 max 0.
No, why doesn't it go 0 maximum? Because the A is negative. So it's reflected. Okay? Let's try number 5, and then I'm going to have you guys do 4, 6, and 8. Oh, I have too many +2s here. Okay. Yes? Uh-huh.
So why there's another 3?
Because it's already raised up 2. So I'm counting it up 3 from here. 1, 2, 3. It went down 3, 1, 2, 3, back to 0, then goes up to the maximum.
I thought it goes 3 up again.
No.
Oh, okay.
Oh, so if the A is negative, then instead of starting up, you just start down.
If the A is negative.
Okay, yeah.
Okay, so on number 5, you guys try 5 and 7. We look at 5, it's a cosine. So think of where it's going to start. What's the amplitude? 2. There's no shifting vertically up. So you have to put these. Where is it going to begin? For number 5. The amplitude's 2, it's cosine. Remember on cosine, at cosine it starts here. It starts with your maximum point. Why does it start there? Because we're talking at 0, the x is 1. But I'm multiplying it by 2, so the amplitude is 2. It's going to start there. It starts with your maximum point. Then it goes to 0, and then where does it go? Very good, to the minimum. And then it goes to 0, and then it goes to your maximum. And it's not a V, it's a curve. I can do very good. Okay, everybody try 6. I'm going to be quiet. It has a -2, so it's not going to start with the x-axis. There's a vertical shift down.
What do you mean? I don't see any difference.
Your art skills
Wait,
here.
in cosine, do you go down?
In what?
If it's cosine, do you go down if it's positive? Is that why?
If it would have been negative, like on number 6, you would start at the minimum point rather than the maximum point.
I know, like, on sine, like, if it was y equals -2, what would you have gone on number 5?
On number 5 was -2,
Yeah.
you would have started here. This was -2, you'd start here, and it'd look like this. Because it's reflected over the x-axis. So instead of starting at your maximum, it's going to start at your minimum. Does that make sense? It's affecting your y.
So you go up first?
No, you'd start here, you'd go up. Instead of starting at your maximum 0, minimum 0, maximum, it'd be minimum 0, maximum 0, minimum. And you'd end at your minimum point. Okay? So are we all working on number 6? 6, it had this -2. What does the -2 do?
Shifts.
It shifts the x-axis down too, right? So we have like a new origin. We're at 0, -2 is where we're talking about all of this. So at 0, -2, this is really my new x-axis. Okay? And then basically, if you want to look at it, you're doing your parent function. You're just doing this one because you've already shifted it down. Now, on here, because it's negative, where is my first? Here, let me mark my axes. Where am I going to start now, since it's -1? I would start at the minimum, right? And then I'm going to go to 0. Okay. Then I would have my maximum, which is right here. And then my 0, and then my minimum. So looking at this one and this one, let's compare it. This had a positive A, so it started at the maximum. This had a negative A, so it started at the minimum. It also got shifted down. Look what the 2 did to this one. It stretched it. This was a vertical shift down. This was a stretch. Okay? Let's just do the last 2. because one's negative, one's positive, and they're both plus 2. So let's compare them. If you're having questions, raise your hand. I'll come help you with these. I'm still going to stay. So now, Armand, you see why you have the negative values, because it goes below the x-axis on it. Hanson, can you take this to the attendance center? Try 7 and 8. And that's as difficult as we're going to get. We aren't doing any horizontal shifting or any cycles. This is nice and basic. Next year you get a lot more.
You don't even have it. You don't even have it. You have to have the tools together somewhat. Let me show you. It's going up by ones. But like, get like it's held. Like this is one.
Okay, back's feeling better.
This is one. This is one hand. This is the other. Okay? It's right there. This whole area.
Who would like to put number 7 on the board?
Yeah, I know. So like, hey, let me show you.
Karen, want to put 7 on the board? You're such a good artist. Who wants to? Daniel? 7?
Actually,
Huh? Sure. Who wants to put 7? Who wants to put 8? Matt, want to put 8? 8? Number 8? No? Bardia? Who would like to? Jalen, want to try?